This is BBC.
How much will you be wanting, sir?
Oh, no. No.
About there, is it, sir?
Oh, no.
There, sir.
Yes, that's it.
Hello. Here's another piece of cake so we can see what went wrong. When the waitress cut the slice, like this, she had in fact made 2 slices. A small slice, like this, and a very large slice, like this. She'd also made 2 angles. A small angle and a large angle.
You can see it more clearly here. A small angle and a larger angle. There are several different ways of cutting that cake, like this, like this, or like this. Now, in every case, there's a smaller and a larger angle, except here. 2 angles exactly the same. 2 angles with a special name, right angles.
I'm using this right angle to help me sort out all the other angles I've got here. This is smaller than a right angle. It's called an acute angle, and that goes in here. This angle is larger than the right angle. It's called an obtuse angle, and that goes on the other side. this angle is smaller than the right angle, so it's an acute angle. And this looks very like a right angle. We'd better compare them. It's very slightly larger, so it's an obtuse angle.
Here's an angle. Is this acute or obtuse? Try and imagine the right angle for comparison. Are you ready? Go. And stop. It is an acute angle, but only just. It's almost a right angle, and right angles are what took Elaine out to sea.
Sailing the oceans used to be a hazardous business. Storms and currents could easily throw the ship off course. And with nothing but water on all sides, finding your way at sea was far from easy. But the navigator did have some help. As well as the sun and stars to guide him, he had his compass, which is inside this casing. A simple compass shows north, south, east and west, which is fine if you only want to turn through right angles. But a ship like this had to be steered more accurately if the navigator was going to hold a steady course in poor conditions and bring the ship safely home. But for the navigator of the Cutty Sark, it's all over. She's now docked permanently at Greenwich, close to the National Maritime Museum, where we can see how they solved the compass problem. Here in reserve, they've got the largest collection of compasses in the world. These binnacles were designed to protect the compass from the weather and to keep it level. The compass is inside. And now you can see how navigators divided up the 4 right angles to fit in many more points on the compass.
And the way they did it was very simple. They took a right angle and halved it. To give them a new direction in between south and east. Except that being sailors, they didn't just fold it in half, they did it like this. With dividers, they marked off equal lengths on each of the 4 arms. They then marked 2 intersecting arcs, like this. And drew a line from the center through the point where they crossed, to give them a new direction in between south and east, which they called southeast. Half a right angle between north and east, northeast. Northwest, southwest. But the navigators didn't stop there. Having halved a right angle once, they halved it again. Quarter right angles. So they now had 16 points. But then even that wasn't enough. You can go on dividing right angles into smaller and smaller fractions and keep on inventing new names for the new directions, but it gets very confusing. So most navigators now use a different system. It's a system that uses numbers to show how far you've turned from north. And it's the system
that this aircraft compass uses. To understand how the system works, you have to imagine dividing the right angle between north and east into 90 equal parts. That's 10, 20, 30, 90 degrees east. And carrying on, 100, 180 degrees. And from south to west, 270 degrees. And back to north, that's 4 90s, 360 degrees.
It's the same system that's used for measuring angles. 20 degrees. And 160, that's 180 degrees altogether. That's the same as 2 right angles, 1 straight line. 100 degrees. That's 280 altogether. And a final 80. £360 degrees altogether. That's the same as 4 right angles and 1 complete turn.
That's 10 degrees. (10 degrees, 120 degrees and 50 degrees, 180 degrees, 2 right angles, straight line. (120 degrees. 300 degrees altogether. (59 degrees. 359 degrees. Yeah. 1 degree short. Must be around here somewhere. Elaine?
This is what Roger's looking for. Just 1 degree. Let's see if it fits. Yes. 359 degrees plus 1 degree, that's 360 degrees. Another complete turn.
No, I'm not filming Match of the Day. It's just that a football ground is a very good place to look at small angles.
Line the camera up on the left-hand goal post and a 1 degree turn coming up now. It's such a small turn for the camera. From there to there, you can hardly see it. From there to there. And now a slightly larger angle. A turn from the left-hand goalpost to the right-hand goalpost is 8 degrees. The camera turns from here to here, an angle of 8 degrees. If I go closer to the goal, the angle changes too. From the edge of the penalty area, the angle between the left-hand post and the right-hand post is 25 degrees. That's a larger turn than before. From here to here.
It's smaller than a right angle, so it's less than 90 degrees. I'd estimate about 50 degrees, but to measure it accurately, I need a protractor. I've put the centre here, where these two lines meet, and I'll line up 0 with the start line. The angle is 60 degrees. Now a more difficult one. And I'll give you a turn. Line the 0 up with the start line. What's this angle? Wait for the green light. Ready, go. And stop. Here's 40, and here's 50. But it's in between, so you'll have to count on from 40. 41, 42, 43, 44, 45 degrees. Now here's one to catch everybody out. And I'll move the start position. Let's have a small angle this time. Line up the 0. Now, be careful, it's not as easy as you think. Ready, go. And stop. It's a small angle, a turn from here to here. But the protractor says 330, and that's a very large turn. It's a turn from here right the way round to here. So how do we find the answer? Well, the problem is this is only half a protractor. It only shows angles going this way. That's clockwise. To find turns going this way, anti-clockwise, we need another protractor.
Like this one. Dark numbers for angles going clockwise, light numbers for angles going anti-clockwise. So this small angle going anti-clockwise is 30 degrees. Now if you've got that, you can give yourselves a pat on the back after the program.
you have the bigger bit and I'll have the smaller bit.
No, no. That's the bigger bit for you and the smaller bit for me. Look, that's the smaller bit.
No, that's bigger.